Let's start section 10.3, taking a look at two-way tables and probability. In this section, we're going to start off by talking about a two-way table. And, we're going to take data or information, and first we have to put it in a table. And so a two-way table is a frequency table that displays data collected from one source that belongs to two different categories. Okay, so we have, let's say, right here, I do have a small two-way table that's represented, and in this two-way table, we have, like, let's just say we have freshman and sophomore, and we talk about their attendance. Okay, so that would be one source. We split up into two different categories. Now we have this first term right here called joint frequency. And so each entry in a table would be the joint frequency. And I have it underlined in red. And so if you take a look at the data right here, the 25, 44, 80, and 32, that would be data that we would be able to put into our table. And so that would be considered the joint frequency, each entry into the table. And the second one that I have underlined in green, and I put the data there in green, that would be the sum of the rows and columns. So if you take a look under like freshman, I've got 22 plus 44, and that's equal to 69. And then 80 plus 32 is equal to 112. So those are like your totals or the sum of each. We'll do it for the columns and for the rows. So for like column present, we have the number of freshmen present, and sophomore, you take 25 plus 80, and that's how we end up with 105. And the number not present would be 44 plus 32, and we end up with a total of 76. All right, so understand that the totals is what we call marginal frequency. The data that's in the tables, we call that the joint frequency. So as we go down, there's three other terms right here, but we can discuss those three terms taking a look at the core concepts. And so in the core concepts, we have relative and conditional relative frequencies. All right, the first one right here is the joint relative frequency. And so when we talk about joint relative frequency, marginal relative frequency, and conditional relative frequency, we are now going to take our data and turn it into a ratio or into a percentage per se. All right, and so it says the joint relative frequency is a ratio of frequency that is not in the total row or the total column to the total number of values or observations. The marginal relative frequency is the sum of the joint relative frequencies in a row or column. And then we have the conditional relative frequency is the ratio of the joint relative frequency to the marginal relative frequency. And then you can find the conditional relative frequency using a row total or a column total of a two-way table. When we work on a problem, you'll probably have a better understanding of what all of this means. But what you're going to end up doing is you're going to take data, let's say, for example, in what we have right here, and if we take like the present freshman, we take 25. What we'll do is we'll divide that by, or set a ratio, putting that over the total number of students, of freshmen and sophomore together. And then we come up with a decimal number, which in turn would be a percentage as well. Okay, so let's go ahead and move on, and let's take a look at our extra practice right here. So in number one, it says, hey, let's complete a two-way table. They give you some information right here, and our job now is to put everything, fill in the blanks. And I take a look and I'm saying, hey, I gotta look for, I need to know 2 out of 3 things to be able to come up with, find a missing spot, right? If we have 3 unknowns, then I need to know 2 out of the 3. So I think one thing that pops out to me right here is we should be able to find the total walkers. Because if I know that the total is 130 and I have 60 on the city bus, essentially right here, it would be x plus 60 is equal to 130. Right, that would be our mathematical equation that we would use to find walkers right there. Or let's use the variable w for walkers instead of x. Should be w plus 60. Okay, so we have 130 and divide that, or sorry, we'll subtract 60 to that right there, and then you'll end up with 70. So there's one right there. 70 plus 60, 130. Another one that I see right here where we could figure out as well would be the total number of tardies. Because if we think about the totals, we know that everything right here in this last row should add up to 130. So this one right here, we would put like, total plus 58 is equal to 130. So if I go ahead and subtract 58 to both sides, we'll end up with 72 right there. Right. And now we're beginning to hopefully fill in the pieces and fill in the gaps. So it's pretty simple. 22 plus what number will get us 72? And hopefully right there, we'll go ahead and put down 50, right? Now let's go across with the rows. Like, 22 plus how many on-time people would get us a total of 70. Okay, so we could figure that out. 22 plus x is equal to 70. Subtract 22 to both sides. And right here, I will say that this ends up being 48, right? And then for the last one, the city bus, if we take 50 people that are tardy, it's going to take 10 people to be on time for it to equal a total of 60. All right, so that right there is how we can complete a two-way table. This part is probably the easiest of this section. Now let's take a look and go down to number 3. Okay, we got quite a bit of things going on here, and we're going to create organize a two-way table, make one, and then we're going to find and interpret the marginal frequencies. We're also going to take this one step further, but we'll worry about that when we get to it. So how could I set things up? All right, it says we have a survey taken of 100 families with 1 child and 86 families with 2 or more children, and determine whether they are saving for college. And so let's think about how we want to set this up. There's more than one way. There is no one correct way of doing this, okay? Because it depends on what you want your columns and rows to be. For myself, let's go ahead. We'll make the top, we'll put responses. Down on the side right there, we're going to go ahead, we'll talk about family size, okay? So once again, we are trying to figure out, are they saving for college? So there's only pretty much 2 types of responses that we're going to have. I want to go ahead and start right here and put yes in the second column and no in the third column. The last column right here will be total. Okay. Now in the first column and in the second row, let's go ahead and determine, well, what type of family sizes do we have? We have a family size with 1 child. We also have families with 2 or more children, so we'll put 2 plus. And then for the last row, we're going to go ahead and put total right there as well. Okay, so we have that now, and let's see what we could put together. Let's highlight a few things. We have 100 families with 1 child, so with that, I can go ahead and plug in 100 for a total of 1 child. We have next up 86 families with 2 or more children. Okay, so let's go ahead 2 plus. I'll go ahead and put now 86 right there. And so now we could figure out our like how many total responses we have. And if we take 100 plus 86, I can go ahead and right here gather that we have 186 for the total number of families surveyed. Okay. Let's go ahead and move on next. It says of those 94 families with 1 children and 60 families of 2 or more children were saving for college. So that would be under the yes category. So let's go ahead. 1 child, we said 94 is yes. Then we have 60 for families with 2 or more children saving for college. So now we can go ahead and figure out the total right there. We take 94 plus 60. We now have 154 for total yes responses. Now we can go ahead and figure out the no responses. If we go across the row, for 1 child, in order for 94 plus x to equal 100, that's going to be 6 responses right there. And then 60 plus some number to get us 86, that'll be 26. So we have 26 no's for families with 2 or more children. So now in the end right here, let's figure out the total no responses, and we end up with 32. All right, so this right here is our marginal frequencies, okay, where we just take the numbers and the responses from the data and we put it all together, and from there we come up with some totals, okay? So it says find and interpret the marginal frequencies. What are some key things that you can gather from what we can get from all the information that's given? So I'll highlight a few things. I think it's always important right here. We'll start off, we have 186 right here, families surveyed. That'll be one big thing. Always important to know the totals. We could say of those, we have 100 families with 1 child. I think another important information is that we have 86 families, and I'll go ahead and abbreviate that, with 2 plus children. You know, if you were to look at this data, what else is important? How about maybe the total yes responses? Okay, so then I'll go ahead and put right here, we have 154 families saving, right? They said they're saving for college. And we have 32 families not saving for college. And college is pretty expensive. If your family is able to save up for that, definitely things will be in your favor. Okay? So that right there is the marginal frequencies. So now we're going to take a look at the relative, okay, marginal relative frequencies. All right, so that right there is where we're going to talk about where we talk about the sum. Okay, we're going to come up with the ratio is the sum of the joint relative frequencies in a row or column. So next up right here in this neat table that I have, we're going to go ahead and talk about the marginal relative frequencies. And what we're going to end up doing is we use the same data, okay? We're going to take the data in our table to the left. I'll go ahead and kind of rewrite things. We got 1 child, we have 2 plus, we have totals. And then we have right here, yes, no, and total. All right, now, because we're dealing with ratio, the total of everything, you know, of everybody we would consider to be like 100% or 1. So right here at the bottom right, I want to go ahead and put 1 right there, because all our numbers is going to um, be decimals or percentages, or think about it as ratios. So for the first one, okay, what we're going to do is figure out, well, what is the percentage or the ratio of 1 children that says yes? So what you need to do right here is, it's quite simple. We're going to go ahead and I'm going to put it up at the top, but you take the data, the total of yes of 1 children that are saving, and we're going to divide that by the total number of respondents, or the family survey, which happens to be 186. And so if you go ahead and take those two numbers, divide it out, you'll come up with your, well, 94 over 86 would be our simple ratio. You could simplify it, but in the for what we need to do, we go ahead and use our calculator, and you get 0.505. Okay, let's round it to the thousandths, and so about 50.5% of the children are saving up, right, with 1 children. Okay, so then let's go ahead. How are we going to interpret or find the 2 plus? Well, what we will do now is take 60 and let's divide that by 186. All right, so then use your calculator right here, and we take 60 divided by 186, and you will now have 0.323. Okay, we round to the nearest thousandths. And for our total right here, we can go ahead and just add the two numbers together, and you will have right here 0.828. All right, and there's your total. Let's go ahead and continue on with the no's. Okay, and once again, this is the marginal relative frequency. That's why we're dealing with ratios and these decimals. So for no, we're going to take 6 and let's divide that by the grand total that we have of numbers surveyed, 186. And right here we have 0.032. Yep, there you go, 0.032. All right, so let's go ahead. I think hopefully now you understand what we're doing. So we have 26 over 186, and that gets us right here, 0.140. And then for our total, we add the two numbers together, 0.032 plus 0.140, and we now end up with 0.172. We can get our total right here, adding the two numbers in the columns together for the yes and no for 1 child, so 0.505 plus 0.032, and that will get us right here 0.537, and then when we add 0.323 plus 0.140, we now have 0.463. And then if you look at the totals in the rows and in the column, they do add up to 1. And hopefully, sometimes depends on the rounding. It may not equal 1 exactly, but it should get very, very close to it. So we did two things right here. We talked about and found the marginal frequencies, and that's right here on the left-hand side. And then we have the marginal relative frequencies, which takes our data based off the totals, and we come up with the ratios right there. All right. So because of number 3 right here, doing both marginal frequency and marginal relative frequency, we can skip number 4 because they're asking you to find the marginal relative frequency right there. And so let's go ahead and skip that. And actually, one more thing right here. in number 3, we actually found the marginal relative frequency and also the joint relative frequency as well. Because remember, the joint relative frequency right here ends up being, remember, is a combination of finding the ratio of frequency that is not in the total row or the total column to the total number of values observed. So when we put everything together right here, we end up finding the marginal and joint relative frequencies. The joint right here would end up being like the values that are in the yeses and the nos, and then the marginal relative frequency will be based in the totals of the columns and rows. All right. Now let's go ahead and go to our last problem right here and take a look at number 5. Okay, so right here, they're going to ask us to find the probability of certain things. And it says, for financial reasons, a school district is debating about eliminating a computer programming class at the high school. The district surveyed parents, students, and teachers. The results, given as joint relative frequencies, are shown in the two-way table. So A right here says, what is the probability that a randomly selected parent voted to eliminate the class? Well, to help us with that, I think it's important for us to, we have parents, students, teachers, but one thing that's missing right here are our totals. So let's see if we could add things together and come up with some totals. All right, so I want to go ahead and create a new column and call this one total on the left. And so what we're going to start off with is let's add the yeses of students, parents, teachers. And so 0.58, 0.08, and 0.10 all together right here ends up equaling 0.76 or 0.76. When we have the no's right here, okay, we're going to add up all the no's, and you got 0.06, 0.15, and 0.03. You end up with 0.024. All right, and there you have the totals, responses of yeses and nos. Now, let's also figure out right here, well, what are the totals of parents that responded yes and no? And that will be right here, 0.64. For students right here, total yeses and nos is 0.23. And for teachers, total yeses and nos is 0.13. All right, so if we think about it, everything right here in this magical bottom right corner, that's all supposed to equal 1. And 0.76 plus 0.24, that equals 1. We take 0.64 plus 0.23 plus 0.13. All of that together equals 1 as well. So now that we have that, it says what is the probability that a randomly selected parent voted to eliminate the class? Okay, so remember we have yeses and nos, and I'm taking a look right here at parents to start off with. And it says probably that a randomly selected parent voted to eliminate. So that would be a yes vote. They voted yes to eliminate. And let's take the number of yeses, or what we know, which is 0.58. And then we're going to have to go ahead and create a probability, would be a ratio. And let's divide that by the total number of parents, and that would be 0.64. So if you go ahead and divide the 2 right there, we'll end up with 0.9. Let's go ahead, if we round that, or let's take it to the nearest thousandths, and 0.0906, which is about, let's say 90.6%. That would be the probability of a randomly selected parent voted to eliminate the class. Next up, it's in part B. It says, what is the probability that a randomly selected student did not want to eliminate the class? So they really try to trick you right here with the wording. And so if they did not want to eliminate the class, I think that would be a no vote, right? So right here for this next part, we take a look at students, and I take a look at the no number, and that's 0.015. So let's take right here 0.15, and then let's divide that by the total number of students, and we have 0.023. So we'll go ahead and divide that out right here, and you get approximately 0.652. 65.5% chance that a student did not want to eliminate the class. Now the last thing right here in C is determine whether voting to eliminate the class and being a teacher are independent events. Now remember, we talked about events that are dependent and independent. Does one outcome affect the other? I don't know, what do you think? Determining whether voting to eliminate the class and being a teacher are independent events. I mean, for me, or if you are a teacher and you had parents wanting to eliminate a class, does that affect your decision to eliminate the class? Yes or no? I think the best answer here would end up being that these events are independent of each other. Unless the teacher really is trying to tell everyone, hey, I don't want this class, or you should get rid of that class, then maybe in that instance that could be true. But I think overall in this problem right here, independent would be the best answer. All right, and that right there concludes section 10.3. Once again, hopefully if this helped you out, make sure you guys subscribe, make sure you like, hey, and you can leave a comment and I will get back to you. Have yourselves a great day.